Welcome back. In this video, I'll be talking about equal complex numbers. When do we say two complex numbers are equal? Two complex numbers, let's say Z and W, maybe my Z is equal to A plus BI, and W is equal to C plus DI. So these two complex numbers are said to be equal. That is Z equals to W if A is equal to B, if A is equal to C and B is equal to D. So that is, we say two complex numbers are equal if the two real parts are equal and the two imaginary parts are equal. So for example, let's say if x plus iy is equal to 9 plus 3i. So don't forget, by the definition of the equal complex numbers, so we say two complex numbers are equal if the two real parts are also equal. So and don't forget, the real part here is what? So it's x, while that of the right hand side is 9. Then if these two complex numbers are equal, then x equal to 9 and the imaginary part will also be equal. That is, your y is equal to 3. Okay, what of this? Can you say it? So if my a plus bi equals to 6 minus 2j, then what will be the value of a and what will be the value of b? By the definition, we say two complex numbers are equal. So if the real part are also equal and the imaginary parts are equal, then here my a is equal to 6 and b is equal to -2. So if that is clear, let me give you the one that is more complicated. For example, the question says if a plus b plus a minus b is equal to 7 plus 2i, find a and b. Find a and b. This is not difficult by the definition. So two complex numbers are equal. So if the real parts are equal and the imaginary part are equal. So now if you check the right hand side, you will observe that my real part here is 7. The real part for the left hand side is a plus b, and you have a plus b is equal to 7. The imaginary part here, you don't need to reckon with this I, so it will be a minus b. So that is also equal to what? So that's equal to 2. So if you check this probably, you will see that it has leads to what we know as simultaneous equation. So if you solve simultaneously, then you are going to have that, let's say for example, if I add equation 1 and 2 together, so add 1 and 2, so then I'm going to have 2a, b minus b will give me 0 is equal to 9. So this implies that a is equal to 9 divided by 2. So likewise, if you subtract 2 from 1, if you subtract equation 2 from 1, then I'm going to have a minus a, that's 0, b minus b. So that is 2b, 7 minus 2 will give me 5. That implies that my b is equal to 5 divided by 2. So then you can conclude adequately that my a is equal to 9 over 2 and my b is equal to 5 over 2. You understand now? So that is, two complex numbers are equal. So if the real parts are equal and the imaginary parts are equal. So to end the video, let me give you another example. Number 2, if 2 minus a minus 5j divided by 1 minus ib equals to 3 minus 5j. So then the question asks us to find A and B. So we have to find the value of A and B. So find the value of A and B. That is not difficult to do. So you can do this in two ways, solution. So let me just copy this out. So since I have let me copy that to other page. So this is the question I have. We have something of this nature. Okay, now, so you can do this in two ways. So the first or the simplest method you can do is that you can just multiply through by 1 minus IB such that you get rid of this denominator, or you divide this by this first before you equate. So I think the simpler one is to multiply through by 1 minus IB. If you say multiply through by 1 minus IB, then I'm going to have what? Let me just roll this one. So I'm going to have 2 minus A minus 5J equals to 1 minus IB multiplied by 3 minus 5J. Okay, now if you open the brackets, I'm going to have something of this nature. That is 3 minus 5J. Yeah, so you can write it that way. Minus 5J, then minus 3BJ, or you can just write it I. In some textbook, they write it as J. So then minus times minus, this give you plus. So this is 5B, and don't forget I times I will give me what? Minus 1. You understand? And I'm going to have 2 minus A minus 5J equals to 3 minus 5I anyhow. So minus 3BI minus 5B. So if I were you, I will collect the like time first so that I don't give myself unnecessary problem. Then I have 2 minus 5A equals to, so then 3 minus 5B, that is the real with real. If I factor minus out here, then I'm going to have 5 plus 3B. And don't forget, you can put your eye here. Don't forget to say two complex numbers are equal if what? The real parts are equal as well as the imaginary part. You know the real part here is 2 minus A, and I can have my 2 minus A equals to what? 3 minus 5B. Then likewise, imaginary with imaginary, that's minus 5 equals minus 5 plus 3B. So you can call this equation 1, equation 2. And simply from your equation 2 here, I think you can proceed further. If I bring this guy here, so you will notice that I'm going to have minus 5 is equal plus 5 is equal to 3B. So which implies that 0 is equal to what? 3B. That gives B equals to 0. And you can now put B equals to 0 in equation 1. Don't forget your equation 1, we have that 2 minus A is equal to 3 minus 5B. Now your B is equal to 0. If you substitute the value of B to be 0, I'm going to have 5 times 0. That's 2 minus A, 3 minus 0. Then if you collect the like time, you have 2 minus 3 is equal to A, which implies that your A is equal to minus 1. it implies that your A is equal to -1. So that's that. You can see it is very simple, and even you can check it out here. You know we have our A to be -1 and B is equal to 0. So if you put B to be 0, then you are going to have 1 at the denominator here. And your A is -1. This will give me 2 minus -1. That is 3. 3 minus 5j is equal to 3 minus 5j. So that's that. If you enjoyed this video, please don't forget to like, share and subscribe so that your friend can benefit too. I will see you in the next video. Thank you.